Again, just to remind everyone again, we are talking about threading today, okay? And threading will be very helpful when it comes to understanding the concepts of parallel execution in Selenium, right? So, in from that perspective, we are learning about threading, right? Okay. So, do you know Java is a single-threaded language or a multi-threaded language, like by default? How many threads runs in Java by default? Anyone?
One thread, main thread, one thread.
Main thread, right? One thread, main thread, right? You're absolutely right. Okay. Now, let us see that, right? How can we see it? We can use debug, right? Let me just do this. Let me say this part. S out. I am a thread. I am a thread. Thread. My name is. There is a class called thread dot current thread. We'll talk about this. Okay. Current thread get name. Let's print this and let's see the name of the thread which is executing our code, right? You can see I have done nothing about threading as of now on this. I'm just creating a normal class and a method, right? And I'm running it. So this is thread demo. Let me current file and let's run this. Okay, it must be cleaning things. So I'll take a while. Let it print just. You can see, right? My name is main, right? It is saying the name of the thread, right? Don't confuse yourself that this is the name of the method, so that's why it is saying main. No, that is not the case, right? You run any method, and if you are using the default way of execution, the name of the method which will come is main. Okay, okay. So one thing should be clear on this part, right? Let me clear that. Here, right? So by default in Java, what is the thread? First of all, Java is a single. I mean, by default, it's a single threaded language, right? You have single thread by default which runs. And what is the name of the thread? The name of the thread is main. Okay. When I say like only one thread is running, right? What does it mean? It means that it can only do one thing at a time. One thing at a time. Okay, at a time. So you cannot do two things at the same time. Okay, that is what it means. If it is a one single thread application or whatever it is, right? If it is single threaded, only one task can be done at a time. Okay, fine. Now, do you know? Okay, see, now again, this is about Java, right? Let us understand from the OS level also, right? How things really work, right? Again, we're not going to go in every detail about this, but let's try to understand from the overall side, right? How things really work. If you see your system, right? If you see your system, uh, let me open Task Manager. Okay, mine is this CPU running almost 100%. No worries. Let's go to this, right? Now here's this, right? If you see this configuration on the CPU side, it shows you how many cores I have, right? I have 4 cores. Okay, I have 4 cores. So I think the name for this kind of a machine which you get, right, once you purchase it, it's called quad core, right? Like 4 cores. If it is 8 cores, it would be octa cores, right? If it is dual core, I mean 2 cores, it says dual core, right? Or a single core. Nowadays, it's almost like quad core or a octa core, right? Maybe more than that. But this is what comes, right? What is a core? And there is one more thing you can see. There is a processor, right? Processor. So why I'm showing you this, I'm coming to that point, right? But try to understand every system you purchase, right, has a core, and within that core, I mean, you can have a processor. Okay, here it says logical processor, right? Remember the name, logical processor. It does not say physical processor. Okay, let's go back. Now let's try to understand this terminology, right? I just wanted to get things very clear from the beginning, so that's why we're discussing all this, right? So when you purchase the laptop, right, what do you say is you go and ask a person, okay, please give me that a laptop with this configuration, right? Let's say you ask the person, okay, give me a, let's say in my case, right, I went to the person, I said, okay, give me a quad core processor, right? I mean system, right, which is has a quad core. What is a core? Okay, what is a core? Just a second, sorry, huh? Please ping it. Okay, quad core, right? Now, what is a quad core, right? You can understand core is like a physical setup, right? Where, right, you can have a processor, right? It is like a physical chip. Okay, it's like a physical chip, right? Which does all the hard, I mean the part, right, of the providing the all you the processing, right? This is what this core part does, right, in your CPU, right? This is that core. If I show you on the net, right, how does it look like? Okay, should I show it? Just a second. Let me show uh, core image in CPU. Okay, not CAU, in computers. Let's see this. You see this, like these are like cores, right? These are like cores, right? So these are like small chips which you can have inside your laptop or a CPU, right? Now, why I'm telling you all this, right? In a core, right, assume that a core has one processor, right? So core is something which is like an outer covering, right? But this is the thing which takes care of everything, right? One processor, right? It has, let's say, one processor. Similarly, you can have a core which may have dual processors, right? Okay, or maybe more than that, right? So so what we are saying is we have one core with one processor. This could be the combination, or we could have one core with two processors, right? Processor one, processor two, or maybe there are other arrangements which I am not aware, right? So this could be the thing. Now, what is the purpose of a processor? Processor helps you to run one thing. Okay, so what happens is if you are running an application, right, it requires a process. Okay, so again, try to remember the terms, right? Core, processor. Okay, and there is one more term called process, and then there's a term called thread. Okay, so we understood what is a core, right? Core is like a physical thing in your CPU, right? And again, there is a within that CPU you could have, I mean, small processors there, right? In my case, I have a quad core which where every core has one processor. So this is the setup which I have on my machine, right? So I have like four such cores on my machine, right? These cores. Now these are physical cores. I mean physical processors, right? They are physically present. If I open my laptop, right, there would be physical chips, right, for these four. Now there could be a terminology which says that I mean you can create like from these four processor you could create more processor, right? But in that case it would be like the bifurcation which is happening at the software level. So I have four processors currently, right? But internally the system is designed in a way that it converts those fours into eight. So that's why if you look at this figure, right, it shows it is eight logical processors. Okay, eight logical processors, right? It's but ideally if I go and check my system, right, open it up, I think it's four processor only, right? Physical processor, right? So again, this has nothing to do with our Java programming and all, but I just wanted to tell you like from where the process thing will come. Okay, now process, right? One processor, right, ideally, right, should be able to work with one process. That is what the point is of the processor is, right? Now I have eight physical logical processors. I can run eight different process, right, without hampering each other's work, right? And they can very well work parallelly. Okay, now process, right? Now within a process, right, within a process, so one process can run one processor can run one process, and within one process, right, ideally, right, I mean not ideally, a process can have multiple threads. Okay, it can have multiple threads. Okay, it can have multiple threads. Okay, so this is thread one, this is two, this is three, this is four, right? We can have this, but when we talk about this, right, all these threads, right, are, see, one process. If you want to run one application, right, it will take one process. Okay, So you can understand, let's say if you want to open, let's say Microsoft Word, right? It's an application. So I think it will take one process. Okay. So one process utilized here. Let's say you want to open Google Chrome. So it will also take one process, right? So the second process is gone. Now you're left with six processes, right? So you can open six other processes, right? Now you may ask me, Akhil, but that is not what I see in my system. I can open 20 of different applications. How come all the 20 applications runs? Now again, I do not have a very concrete answer to it, but try to understand. There is a concept of scheduler, right, in your systems, which very quickly, right, schedules, I mean, which is like a round robin trip or maybe some other arrangement which it follows, due to which you do not get the feel of like these are not running parallelly. Okay. Ideally, a process can run only one application, but the context switching is so quick that you don't realize that part. Okay. And it gives you a feeling that okay, you can work with so many applications being opened up. But try to understand, as you keep opening up multiple applications, right, your system performance keeps coming down, right? I'm sure you would have realized that, right? And that is one of the reasons because of this part, right? Now, within a process also, let's say you want to work with MS Word, right? Within that MS Word, let's say within, see, MS Word itself, it's a very big application, right? You can do hundreds of things inside this. Now let's say you have written a logic or you have a macro there or something, right, which is reading it from the internet, maybe some value, right? And similarly, and at the same time it is also writing something, right? So you can understand within a single application itself there is a need to do two things, right, at the same time. So in all those cases, right, these threads will help. These threads will help in that single application. In that single application, right? Right. So it's not that this thread one will work on MS Word and this thread will work on Google Chrome. No, this is not like that, right? All these threads, right, within a single process, ideally should be working on the same application, but maybe different areas of that application. Okay, right? This should be, we should have some understanding around it. I'm not asking anyone to become an expert, even neither I am an expert, right? I'm telling you all this from what I have observed. Okay, now let's go to our point now, right? Why I'm telling you all this. Let's first understand why do we need to know about threading, right? In our case, what we need to do is we need to open multiple browsers, right, for our parallel execution. Let's say I want to run on 4 different browsers at the same time. I want to run on Chrome, right? I want to run on another, again another instance of the Chrome. The third instance would be Firefox, and the last would be Edge. Okay, I want to run this. Now, you, at least we know as of now that all of this operation, right, if I had to run, they require 4 threads. Okay, a single thread can work on a single item, right? It can only do one thing at a time, right? But I need to run these, parallelly, right, concurrently. So what I require is I require one thread which should be attached to this, and it should do everything on the Chrome. Another thread should get attached to this instance, and it should do whatever it is required here, right? Similarly, T3 here and T4 here, right? Okay. Now, why I'm coming to the point of the process and thread relation. You may think that okay, Akhil, I see T1, T2, T3, T4 threads. So there are only 4 threads. And I know that a single process can have multiple threads within it, right? You are correct. But again, I'm trying to focus on the point that a single process, if it has multiple threads, right, those threads would be used in the same application. It is not that those threads would be used across the application. Okay, maybe that okay, within the same process you are able to do with MS Word also, Chrome also, and maybe some other things also, right? No, that is not the case. So in this case, right, since you need different instances of the browser which will work in isolation, and everything right over there would require a separate process to be running. Okay, so what happens here is, right, you see it as a thread, right, but ideally what happens is a process, right, attached to it, and a thread from that process is given to this Chrome, right, to run. Okay, right? And again, I'm not saying that if I have a 8, let's say if I have a 8 physical processor, right, let's say physical processor, so ideally how many process I can run? Only 8. And in every process, right, in every process, how many threads I can run? Let's say one thread, right? So ideally in total how many threads I can run? Only 8 threads. So if I have a octa um processor, right? If I have an octa processor, which is an 8 processor, right? Ideally, I should not have any trouble running my framework, right, with at least 8 threads. I should not have any trouble. Okay. But as soon as you start running the ninth thread or the 10th thread, right, you may start to seeing some of these strange behavior, right? It may not be able to cop it, I mean, to cop up with the concurrency level, right? Or it may itself say that okay, ninth thread is not allowed. Okay. Again, it depends, right? How your system is designed, which I do not have much insight on, right? But what I'm trying to say is, if you decide to run your cases in parallel mode, right, you should be dependent on how many processors you have. Okay. So let's say you want to run on 16 instances of the browser, right, and you have, let's say, 8 processor machine. What you should do is you should buy two such machines, right? One 8 processor and second 8 processor, and you can distribute your load across them using this Selenium grid, right? This machine will run 8 threads, this machine will run 8 threads, right? And you will be able to run your execution accordingly. If someone knows a way where you can have a single machine and you can run multiple threads, let's say 16 threads on a octa processor machine, then please let me know also, right? Because I am aware of the process that you can have a machine, let's say a octa processor machine, and then you can just run 8 threads without any difficulty, right? Okay. So at least we need to first understand why are we learning all this. I told you what is our objective. We want to run multiple browsers, right, which can help us running. Okay. So one is this need. Now, so this is on the OS level, like how things work. So I think we're good with this, right? Let's move ahead. Now let's talk about Java, right? In Java, I told you by default only one thread runs. Only one thread runs, which is by default, and this is called as main. Okay, this is the name of the thread is main. Again, by I think it's the obvious reason over of the main is because you start things from the main method only, right? When it comes to your execution. So that's why the creators of the Java, right, they defined that thread name as to be the main only. Okay, so main, right? Now, what we need to learn in Java, right? So first of all, I told you, right, Java runs only in one thread, and we need to learn how we can create more threads, right? So what is the understanding we need here? We need to know about the class called thread. Okay, one thing we need to know. So this is the class. Okay, we need to know about an interface in Java which is called Runnable. It's an interface. The third thing, we need to know about a class called ThreadLocal. It's a class. Okay, there is, again, the fourth thing is a concept. Again, it's a class also, but you will not be able to directly use it because it is marked private, right? So you cannot use that, right? You cannot use it, but the name of that class is ThreadLocalMap, right? Okay, so it's a class again. So if you know about these three things, I mean these all things in Java, right, you are sorted. You do not need to know anything else, at least from our perspective of running our cases in parallel mode. We need to know about all four, right? Just these four. That's it. And even in this, just a couple of methods, nothing more. Runnable interface, right? I'll show you what is a runnable interface, but it has, I believe, a, a single method inside this with the name as run. Okay, there's a run method inside this. So since it's an interface, whichever class implements this will have to implement this run method. Okay, so this is the one method which you need to know. Thread local. There are three methods inside this which we need to know. What is the thread local? I'll come to that part. But what we need to know is we need to know about the get method. There is a set method and there is a remove method. That's it. Okay. Ideally, you have to know about only these. I mean, and when it comes to our implementation using TestNG, the parallel mode, only this part is required. You do not even require to know about thread, runnable, thread local map. Okay. In that case, this is also not required. But for the overall understanding of threading, how it really works, we need to explore all of them. Okay. So, but again, I am saying when it comes to implementing our part of running parallel execution, right? This is the only thing which you need to understand. But to make some understanding on this, we require understanding on these part also, right? Right. So let's start our process now. Okay, now how things work. Okay, one more thing which we'll cover here, right? For a thread, right? A thread. So there are a couple of terminologies, right? One is thread, and another terminology is thread of execution. The third line, I mean, the third word which you should be knowing is with, see, you remember, right? We discussed about heap memory and call stacks, right? We've discussed that how if you write a program and you run it, right, how those two are used to interact, I mean, to store the objects and the data, right, inside them. We have discussed that in our discussion of Java. Now what happens is, see, heap, see, this is what we have understood, like there is a call stack, right, where what happens, I'll talk to that part. So, and this is a heap, right? So heap is used to store objects, right? Objects. So this is for the objects, and over here we use it for storing local variables, right? Local variables, method names, right? Whatever you do are all placed there in the call stack. This is what we have learned, right? And if there is a variable, let's say uh, string s1, right, so it will be placed here, and value of, let's say, Akhil would be placed, because it's an object, it will be placed here and it will be mapped to this, right? This is what we have learned. Now we have learned, we were at that point of time we were saying that there is only one call stack and only one heap memory, right? So even now, right, heap memory is only one, which is this, right, which is this. But whenever you start creating multiple threads, right, every thread will get its own call stack. It's an important point, right? Every thread will get its own call stack. So let me write it here. Every thread gets its, okay, gets its own call stack. Okay. By default, when you are not implementing more threads, so for which thread this call stack is for? Main thread. Okay, by default. This is for the main thread. If you start creating one more thread, let's say by name T1, it will create a call stack for itself, right? And whatever will be happening because of that thread, right, that local variables and everything, right, will be placed on this stack, not on this stack. Okay, okay, fine.
The heap memory is the same, right?
Yep. If someone wants to say something?
No, I just wanted to ask. So the heap memory will be the same, right?
Yes, I think it is same. It is not like you have heap memory separated out for every thread. No,
Okay.
heap memory is in a single place, but for every thread you get a different call stack. Okay, okay, fine. Right. So these are different terminologies. What is thread? What is thread of execution? We are coming to that part, right? Now I told you about the methods, right, which you need to know. In the thread class, right, there is one more thing which you have to, I mean, there is one more method which is called as start. Okay, this is something we have to talk about. There is one more method, okay, which is called as current thread. Okay, current thread, right? And right, and if you want to get the information about the current thread, every thread, right, every thread gets a name and ID. Okay, so these are like its unique things, right, which you can provide, right, a meta kind of information which you can provide to every thread. And if you want to see like what is the ID and name of it, you can make use of the thread class, right? It has a method called current thread which will give you the access to get name and get ID. Okay, right, this is what we need to know, and let's start seeing them, right, how it is done one by one. Okay, one more thing, sorry, left is we have to talk about thread life cycle. This is the important part. What is the life cycle, okay, of a thread? Let's start. Let's go to our code now and let's see this. You can see by default Java has only one thread, main thread, and if you use, see what I've written here, I've said thread dot current thread. Okay, it says current thread. Let's say I had 4 threads which are running T1, T2, T3, and main, right? And currently I know that this piece of code is being run by main, or let's say by T1 or by T2, right? Whatever the thread is, right? Java will be knowing about it. How it will know about this? by through this method, current thread. So whatever thread would be running this, right, it will get the context of it, right? And for that thread, right, if you wanted to see what is which thread is running this, right, you can use this method get name, and it will print the name like it is printing here. Or what you can do is you can, if you wanted to access more methods, right, you can see the thread group, the state, right, priority, and all that, right. Again, you don't have to go in any of this. Just stick to this get ID. Okay. Okay. Does anyone know what is this stack trace? We have seen a stack trace when we get to the exception, right? We see a stack trace, right? Right, everyone?
Yes.
What is that stack trace? Is it only happens in case of exceptions? At least this is what we see, right? That only in case of exceptions it prints that stack trace. But what is that stack trace? It is a call stack trace. Okay. What it does is it prints that call stack in a reverse order. That's it. That is what a call stack, that stack trace is. It is a trace, right, of that complete stack. That's it. Whatever method, right, you have currently on that call stack, it will print it in the reverse order. I mean, the one on the top would be printed first, then one which called it and all that, right? If you want to see how many methods, right, or what are the things which are placed in this call stack, you can just use this method, get the stack trace, right? It will print all of that, right? I can do that, but again, that is not our. Okay, I'll show you. Okay, I'll try to show this, but let's just focus on our part today. Get ID, right? Get ID, get name, right? We can print this. Let me run it again. Earlier it was saying, okay, let me write it here. Get name, and let's copy this and print the ID also for this. My ID is, you can see, right, I am not assigning an ID to it automatically has that ID, right, and the name also, at least for the main thread, right? So let me run it again. Let's see what ID it prints. You can see it says ID as one, right, and the name of the thread is main. Okay, and this is the default thread. I have to do nothing about it. It is just already there. Now let's move our topic ahead, right? Now let's say there is a need. I want to create a new thread. How can I create a new thread in Java? Right? Let's do it this way. If you have to create a thread in Java, right? Right? You should create a new class first of all. I will create a thread. Let's say I will term it as my thread one. Okay, my thread. My thread. Okay, my thread one. Okay, let's say this is the first thread which I'm going to create. It's a normal class, right, everyone? Now, the process of creating a thread is that you have put it again. See, okay, when I'm telling you all this, right, it does not, we do not have to do any of this when it will come to automation framework part, right? In the automation case, test ng does all of this internally, right? We do not have to do any of this. Okay, in test ng, in the automation framework, we just need to make use of ThreadLocal. Okay, but to understand how ThreadLocal helps us there, we have to understand how threading works. That's why I'm teaching you all this, right? Now, what I told you is there is a interface called Runnable, right? And that is the key to generate a new thread. Okay, so what we need to do is a Runnable is the interface. So what do we do with interface? We implements Runnable. Okay, now let's go to Runnable first. This is the interface, and you can see it has only one method called run. Okay, called run. If you want to create a new thread, right, you have to create a class and you have to implement this interface, which we did. What we have not done is we have to abide by the rule of interface, and we'll have to provide the implementation of that run method over here, right? So let me provide that implement methods run. Okay, and this is the part, right? Now, whatever I want to do with this new thread, right, I should write all that logic inside this run method. So what is the point of this run method? the importance of the run method is whatever you want to do with the new thread, right? Everything which it has to do, you should write it here in the run method. Okay, whether it wants to call a new method, whether it wants to print a for loop, right, and all that, right? It should all be doing inside this run method. Okay, every that logic should be residing under this. So let me write it here. I'll write the same thing which I did here, right? This part. Let's grab it. Let's put it here, right? I am a my thread one, right? I am a my thread one. My name and ID. I'm not pointing, right? See, this is I'm trying to get, right, but you can see this is the thread which I am creating, right? And I have not provided a name and the ID to it, right? Okay. So one is okay. So this is this part, right? Now what I did is I'm telling you, if you want to create if you want to create a new thread, what you need to do is you need to implement an interface called Runnable, and as part of that process, you will have to implement the a method called run, and whatever you want to run through that thread, right? You will have to write all that logic here, which we did, right? Okay. So this is the logic which is written, right? Now the next point is how to run this thread. I have written here what the thread needs to do. Okay, this is fine. But how to invoke that thread? That part is still pending. How to do that is you will go to see this is your entry point to your program, right? We are clear about this. Main is the entry point. And if we run this, who will run it? The main thread will run it, right? So main thread is running this, right? Now I want to create a new thread, right? And for that, I have already written the code, right? But try to understand this thread is not running by default. You will have to run this, okay? You have written the logic, which is fine, right? But this thread needs to be started. Otherwise, it is created and it is dusted. It is not being used. So if you want to use it, what you have to do is you will have to create the instance of the thread class first of all. So I'll create an instance of the thread class, thread, let's say T1, and I will say new thread here. Okay. So this is a new thread being created, right? And now what I'll do is I will say T1 dot start. Okay. So this is the process here. So what you did was you created a class, you provided the logic, whatever you have to do with that thread, and then you will have to create the instance of that thread. Okay. And then start it. If you don't start it right, it will not run. Right. Okay. One thing which I must did, what I also need to do is I need to create the instance of that class, right? So let me say uh, it's a thread one equals to new my thread, and that's it. And here I need to provide this thread one. Expected zero argument but found one. Okay, just a second. What am I doing here? And this is the logic, right? We create the instance of the class, which we did, and using thread one. Thread one. But, no, just a second. I am doing something wrong. Just a second. We do not have a start method, so this code is fine, right? This is where I need to make sure I'm doing the right part. I need to run it through thread one, right? Okay, my thread. Just let me go. Let us go there. Does it accept? Yes. Here I need to provide, right? I have to provide it here. Yes. Restart. Okay. Let me run it and then I will explain you what I did. Okay. Let us see whether it is running or not. So what I am expecting this to run, right? First of all, the control of our execution starts from main. So it will go to this line. JVM will run this main method using which thread? Main thread. So at that point of time, how many threads are running? Only one, which is main. it will run, it will print this information. So the same information will be printed again, right? This part. Then I am creating the instance of my class, which I have created, right? And the purpose of that class is that I want to start a new thread, right? But just creating the instance of it will not start the thread. But now I will know that what exactly the thread needs to do by doing this 8 line. And why it is that? Because I have already implemented a run method inside this. Okay. Now what is required is here, right? It starts. This is the part which creates a new thread. Okay. And here, right, you start that thread. And above here, right, you did what? You just you can see define the work which this thread will do using a run method. Okay, let's run all this and see what do we get. Okay, so let's see now. You see this? What I'm getting here is it says, see, okay. First of all, I'm doing a dry run here, right? Just try to understand. Main method started, right? Main thread started, and it went to the main method. I mean method A, right? It printed this line. So this information is about that main thread, that single thread, right? Now here, right? I wanted to create a new thread. So what I did was I created a new class and implemented this runnable interface. And as part of this, right, I have to provide the logic of this run method, which I did. Okay. Now, so this is all part of creating the thread, right? So this is the first job which I've done. I've created a class, implemented the runnable interface, and give the logic to my run method. Now, what I need to do is I need to create the instance of that class, which I did. This is the third part. The fourth part is I will have to create a new thread. How do you create a new thread? By doing this new thread part, new thread, right? And what exactly that thread needs to do, right? We are providing here, right? By this instance here, okay? And right, but even you do this, right? It will not start the thread. Thread will only get start, or it will only get in the running state when you run this method t1.start. It will start the thread, right? It will start the thread, and once it started, right, the what it does is it goes to the run method and runs every line of code which is printed there. Okay, and that's why it printed all of this, right? Let me go back on the board and just try to mention it again, right? So how what I am saying is to create a thread, right? To create a thread, the complete process, right, is this: you will have to create a new class, create a new class, and implement runnable interface. Okay, so you will do this. Second thing which you need to do is implement the run method. Run method is a part of which interface? This interface, right? That's why you have to do it anyhow because of the rules of Java. The third thing is what you need to do is, so this is like a new class, right? In a separate class. What you will do is you will go to wherever the invocation is happening, right? You will go in that class, and then you will have to create the instance of this class. Okay, so let's say create instance of this above new class, right? New class. So do that. Once you create the instance, right, what you can do is create a new instance of thread class, instance of thread class, right? And in the constructor call of this method, right, in the constructor call of this class, in the constructor call, provide this instance. Okay, provide this instance. And then in the end, right, what you do is to start a thread, to start the whatever that thread needs to do, right? You want to start that process. To start the thread, just do what? Do this. You have created the instance right here. Use this instance, right, and do a start on this. Okay, this will do what? It will go and run this run method. That's it. This is the whole process of creating a new thread and do whatever you want to do with the thread. Okay, and now what you have is you have two threads running. One is the main thread, which was already there by default. So it was going. If you would check the call stack of this, right, it will have that main method inside this, which it was running, right? Whenever it's again, right, it had this, right, and on this, right, you will, if you would go right here, right, let me try to do this, right, and we will print that stack trace just to make you aware, right? If you would see this here, right, this main, this is all, this line is run by main, this is run by main, this is run by main, this is run by main, right? This is run by main, even this is run by main, even this is run by main, right? What is run by this new thread, right? Okay, not this method, right? These things, right? These are the only things which are run by the that method, right, over there. I mean that next thread, the new thread. So what I'm saying is this is for the main thread, and we gave the name, we created a new thread called T1. So it will be running those two lines, right, whichever it has to run. Let me just show you by printing all of that. Get name, get ID. If you wanted to know about how many threads are there, right, currently running, I think there is, you have a method here. Just a second. Count, active count, right? You can get this and you will get to know how many threads you currently have running in your Java application, right? So you can get that. I believe this is what it gave. Active count returns an estimate of the number of active threads in the current thread group, right? Subgroup. Okay, fine. Okay. So this is what it is. But again, I don't have to go there. What I wanted to show you is we wanted to print this stack trace, right? Stack trace dot get stack trace. So within the stack trace, what does it return? It returns a stack trace element array. So it is an array, stack trace element. So what I can use is I can use a for loop because it's an iteratable item. So I will use the enhanced for loop. Stack trace element, let's say E, and I will print this as out E dot, let's say, get class. Will it print everything? Let class loader name, class name, and all this. Let's see if it prints anything on the toString part. Okay, and I will only print this on this part, right? Let me, so that I can see some information, right, what it has. And let me grab this and also run it. Let me just say, right, main, so that we know this is the main which is printing all this, right? Main, and let me grab this, and I will also print the same information here, right? Let's see whether it has anything or not, right, after running this. So this is not the main, this is P1 thread. Let's run this. You see what is happening here in the main thread, right? This is for the main. In the main, you can see uh, it even has this method, right? Okay, let's try to understand this, right? See here, when you are running in the main thread, right? What gets stored there, right? These statements does not get stored on the call stack, right? These are nothing, right? These are just the mere invocations which are happening, and it will be done and dusted, right? But what you have is, you can see here, first of all, the main method got added to the call stack, right? Which is here, Java line number, which is Java 17 here. Okay, right? So main is the first method which is there in that call stack of the main thread, right? Once it was there here, right? When it is running this line number 17, because this is where we are currently, right? So at that point of time, everything above this, right, has been executed, right? Okay. So here what is there on top of it is this method which is currently running. So it is showing you that method also. But these are all placed on that call stack of the main thread. Once you finish this, right, and you went into the start method, I mean this start thing, the control moves to this run method. And you have already printed this, right? Now, if you're trying to print this, right, see what do you have here. You can see it has the run method. This run method is in the new stack. So this run method, right, is in the this thread, right, not in the main thread. Okay, this is not in the main thread. This is under the T1 thread, the new thread. So these are two different call stack 2, call stack 1. And you can see again here also, you had the, because you were calling calls that stack trace, so that's why it is printing that stack trace also here. Okay, but again, the point over here is that every thread will have its own call stack. Okay, right? Okay, now we created one such thread here, right, which is this one. Using this class here, right, I have created one class. Let me create two threads now. What I'll do is, again, see how simple it is now for me. I'll just use it, and now I will create a second thread. Okay, I'll create a second thread, right? And what I should ideally do is I should create a new instance of this thread also, this class. So I will say thread 2. Okay, if I wanted to do the same operation again, right? So I'll just copy this and paste it here, right? So T1 start was done, and now I want to run this the other thread also. Let's say T1 dot start, sorry, T2 start, right? So what will happen now is, now we have three threads running: main thread, T1 thread, and T2 thread. Okay, these are three threads running. Okay, let me run this, and thread demo. Yeah, let's run this. Okay. Okay, so this is a part of that same thread group. That's why it is showing 0 and 1 here itself. Okay. But I don't want to go into the thread group discussion, so I'll not discuss that part. But try to understand again. This part is same as earlier, right? And over here, right, when it is running, you can see it created two threads within it. Thread 0, thread 1. I am a thread 1. No, just a second. Let me read this. My thread is thread 0, thread 1. My ID is 17. See, the ID of this thread is different. Thread 1's ID is different, right? I have to change this. Okay. I've written my thread 1, right? I should use what? I should not use this. I should say my thread, my thread. Let me run it again. And here also I'm printing T1. It should be thread only, right? Let me do this also. Thread. Let me print the current thread name. Na? It would be much better. Current thread name. And I will add here what? Plus equals to 6. And it would be much better now. Let's run this. Okay, so you can see, but you, okay, if you're noticing this, right, see here what is happening. This main thread, the way it was running, this is running very fine, right? It is printing this line, it is printing this line, and then it is printing the stack trace. This is as what we have documented there, right? But when you see this line, right, over here, this is like, it is giving, like, it is not in the order, right? It is not in the right order. Ideally, what we did was we first called this thread T1 start, okay, and then T2 start thread was running, right? So ideally, what should have happened is the T1 start, I mean the T1 thread, it should have started and would have completed, and then T2 thread should have started and completed, right? But this is not how we are seeing here, right? Because as per the output, we are not getting that feeling. If you would see this, right, thread 1 is like the second thread, right? Thread 0 is the first thread. Here it is printing the details of the second thread first, right? Which is as per our expectation, which is not right, but it is printing this. Similarly, you can see this, right? Right? I hope it is making sense, right? What I'm trying to say. What, and you can see, right? Thread 1 0, thread 1 0, thread 1 0, thread 1 0, right? It is doing all of that. It is like a mix and match, right? It is not in the right order. Ideally, what should have happened is this line should have executed, then this line should have executed, then this line should have executed, right? And then this line would have executed. Then thread one should have executed, then this should have executed, then thread one again, and then this one, right? I mean, if you follow this pattern here, right? This is what it should have printed, but this is not the case. Okay, so I'm coming to this part, right? All of this is happening because we do not have an, I mean, we are not able to comprehend this because we don't have the understanding of thread life cycle. So I'm coming to that part now. Okay, but how to create a thread, right? How to create a thread and how to use that, right? It should be very clear. If you want to have a new thread, create a new class, implement the runnable method. Whatever you want to do with the thread, mention all that logic inside the run method. Once you do that, go to the to the class wherever from which you want to trigger this thread, right? Like this. So you will go into the thread demo class like this one, right? And what you need to do is you need to create the instance of your newly created class which you did, right, for that new thread, right? And then create the a new thread using the thread class, right? And provide that class name as the input to it, right? And then run the last step, which is t1 start. Okay, the start method needs to be invoked. Okay, okay, fine. Now let's understand the life cycle, okay, of the thread. What is the life cycle of a thread? Which is very important. Okay, let me correct this. Okay, so I'm now about to write the what are the different stages, right? The thread goes through. Okay, the first stage is called new. Okay, okay. When is the new state? What happens here is right. So when a thread reach this is the initial stage, right? This is the initial state, right, of a thread. When do you reach to the state? You reach it. See, what I did was I created a class. Let me create a class. Let me get a class up in the top, right? My thread implements runnable. Okay, runnable. And as part of this, what I had to do was I have to implement the method called run public void run. And let's say I want to print, sorry, I want to print s out a thread name, right, which is thread dot current thread dot name, right, get name, whatever that method was, right? So it will print that, right? It will do this. And what I was doing here is I will go to my actual class where from wherever the main method is placed or wherever that control is currently. I will go to that class and I will create the instance of this class, right? So I will say my thread, let's say t1 here, right? And new my thread like this, right? Okay. And when I do this part, see here, when I write this line, thread t1 equals to new thread, this to be here, right? When I do this, at this point of time, your thread reaches a state called new. Okay, at this line. So whenever this line gets triggered, right, a thread is created because you're creating a new instance of it, right? A thread is created, but it's not started, it's not running. Okay, it's just created and it is sitting idle. It will not do anything. Okay, if you want to do something with it, you have to call that start method, which we have not done, right? So this is the first state, new. And how do you reach it? When you run this line. So if we go back to our code, when did our thread reach the new state? When we wrote this line, right? We are good with this, right? This is the first state of our life cycle. Okay. Now, after the new state, right? Try to understand when you do a new thing, right? What happens here? Okay, there is one more thing which I wanted to tell. Okay. When you create a new, right? At this state, the call stack, right, which I'm telling you that for a thread gets created, it does not get created at this state. Thread call stack for this thread, right, is not created yet. Is not created yet. It will not be created if it is a new state. It will only get created when the thread starts. Okay. So the next state is, I mean, the next state which will go in is a start one, right? Is a start state. Okay. It's a start state. When do you reach to the start state? When you use this T1 and you do a say T1 dot start. Now your thread, right? Okay. I told you there are two different terminologies, thread and thread of execution. Okay. The thread, in when we say thread, right? This is what the thread was created, right? Okay, the thread was created here itself because we did a new here, right? But it did not do anything, right? The thread was not doing anything. It was just sitting there. When you invoke this start method, right? Only then the thread starts doing the thing which it has to do. And when it does it, right, we call it as thread of execution. Okay, so there is a difference, thread and thread of execution. When does thread of execution happens? Whenever you call the start method. Okay, again I'm just telling you different terminologies. Nothing is required for you to understand on the automation front. Okay, you will not do any of this. Okay, right, T1 dot start, right? So the thread will start here, and when the thread will start, a new call stack gets created here. Gets created here. And whenever you call a start method, right, what happens next is it goes and run what method? And it goes and run the run method, right? I should write invoke here. And it goes and invokes the run method, right, for that thread. So what happens at new? Nothing happens. You just create a new instance and a new thread is created, but it is not doing anything. No call stack, nothing, right? When you say T1 dot start, right, the thread of execution starts. It will, a new call stack gets created, and it will move the control from here to the run method, right? Right now, okay, one more thing. So this is the start, right? I am making it very oversimplified. Okay, there are more stages here. New start, right? Let's say whatever you have to do as part of your run method got completed, and you reach the end of the run method. Okay, you reach to the end of the run method. Now, what will happen, right? What will happen is, once your run method, right, gets completed, right, your thread completes. Okay, your thread completes, and what is the state name we call it as? It then reaches the state called dead. Okay, when do you reach here? You reach here when the run method completes, right? Okay, right. Yes. So what happens is, in case of start, in case of once the run method complete, right, you reach here when run method completes. Okay, you reach here when the run method completes. Now what does it also means is that the call stack which you created, right, at the start, and once that run method is completing, this call stack will also get dissolved. Okay, call stack will get dissolved, so it will not exist anymore, right? This is the part. Okay, now, and what it also means is that this thread is not a thread of execution anymore, because it cannot execute anything else now. Okay, okay, so not a thread of execution anymore. And one important thing to remember is, if a thread has been started, right, if it has been started, right, it cannot be started again. What I mean by this is, if you run this t1 dot start, right, you have already ran this on this thread t1, right, you have already done this. Let's say it is still running and you again do t1 dot start again. Okay, let's say you have a run method which will take almost 5 minutes to run. Okay, and then what you're doing is you're again using T1 at some other line and you run this T1. Let's say you did first this part, right? And the let's say it is started executing thing, right? It is still executing. It is someone here, right? It is somewhere here, right? And you again did what? T1 dot start from somewhere, right? You did this. It will throw an exception. It will throw an exception. It will say the thread is already started. You cannot start a thread again. Okay, this is the rule of Java. Now, so I am taking a case where the thread is already running. What if the thread has already completed? Let's say the 5 minutes are over, and then I will say, okay, let me start this thread again. Can I do this? No, you cannot do this. A thread once started, right, cannot be started again, whether it is in middle, whether it is still executing or it has completed the execution. A thread has to run only once. That's it. Once it is done with the job, it will move. It ceases to exist. It does not exist anymore. You cannot start it again. Okay, right? So a single thread once started cannot be restarted again. You should remember that part. Again, you should remember all of this from the interview perspective, nothing from the automation perspective, right? The usage which we have to do in our case, right? Again, I'm telling you this, you do not have to do any of this, right? Now, there is one more terminology, right? Yeah, Fizula, please.
Yeah, just one dot clarification here. So thread is completed. It started and got completed. It's done. So can't we use it again once again?
No.
No.
If you
Then
try
what
to
is the
do
point?
no, you will have to get a new thread then.
What will the thread be? It'll be still there in the pool, right?
No, it will get completed, right? Garbage collector will take will does its part, right? It will see that
Okay.
okay, the thread has already completed. It will pick it up and then put it in the dustbin then, right?
Okay, got it. Yeah. Thanks.
Right. But again, right? See, when we talk about the multi-threaded applications, right? They are not restricted only to this concept, right? They use thread pools and a lot of things, right? Which I am not an expert on, right? So maybe there is a way that again for a single thread there is no way, right? If it is started, it is started only once. You cannot do it. But there would be a way where you can create more such threads, right? Once it's completed, okay, then you will get a new thread to run something new, right? That is how, but that is something an internal architecture which of that application which supports that part, right? But for our case, again, it is not required and we don't need to know about any of that. But we should know about a thread lifecycle. Okay. One more thing which I want to tell you, right? If you remember, right, during our learning, right, of Selenium, I kept writing something like this. Just a second, huh? Just a second. Here is my mouse. Oh, here. Okay, right. Okay, right. So during our execution, right, of learning Selenium, right, I kept writing this thread dot sleep. Remember, everyone, I was doing this multiple times during our learning of Selenium, right? What does it really do? Right? What does it really do? Right? Try to understand. Forget about creating a new method and forget about creating a new thread and all, right? Try to understand that in our Selenium part, right, we did not create a new thread, right? We always use the default one, and the name of the thread was what? Main thread, right? Now, the main thread, that main thread, which is the default thread, right, gets created and managed, right, by the JVM, right? We do not have to do any of that part, right, for the main part, right? So it is created and it is started, right, by the JVM. Okay. Now, at that point of time only a single thread was running, right? So it would have already surpassed this stage, right? So this is stage 1, this is stage 2. So stage 2 was already done. I was already executing something, and in between I went and said thread dot sleep. What it did, it just went there and made my thread to do nothing for that duration, right? This is what I did, right? So what is happening there is I am restricting, right, I'm somehow blocking the execution of my thread, right? Again, there could be multiple reasons for blocking the execution of thread. Maybe my thread, let's say I have to, let's talk about main only, right? So we have a main thread, it was doing all of that, right? And I wanted my browser to take some time so that it has some breathing time and it can get loaded completely, right? And for that duration, I do not wanted my main thread to do anything, right? Let's say this is 5 seconds. So what I would write it, I would say thread dot sleep, right? And I would say 5 seconds, right? What, however I provide it there, right? And what will happen is, once this gets triggered, right, the thread, right, will go in a sleep state. Okay, it will go in a sleep state, right? It will go in a sleep state and it will not do anything. Okay, that is what I have been doing. And which thread we are talking about? The thread which was executing. Which was that thread? The main thread, and that was the only thread in our case, right? Now, why I'm telling you all this again? Because what I wanted to reflect here is that there are not only 3 states, there are more states. What you can do is, it does not look like this. Okay, new, start, dead. Let me tell you like how does it look like. It looks like this. New, it starts from here only, right? Then instead of a start state, right, what you have is a runnable state. Runnable state. Okay, you have another state after this which is called running state. Running state. Okay, this is something which you can think of like a start, right? It is doing something. Okay, and you can move from running to runnable. Runnable means that it is ready for execution, right? It has been created, the t.start method has been executed, but the execution has not started. I'm coming to that part, why the execution would have not started. Okay, I'll come into that part, but try to understand that here t.start has been invoked, but execution has not started. Okay, when you are on this state, execution has started. Execution has started, right? Execution has started, right? Okay, and one more thing is, from the running state, right, you are currently running, and what I can do is, I can move this thread into 3 different states. What are those states? I can wait. I can move this thread into a wait state. I can block this state. I can block this thread, right? And I can sleep this thread. Okay. So try to see these arrows, right? How the arrows are moving. So let's say you create a new thread. How you do it? Thread t1 equals to new thread, right? You reach this state. You then started t.start, right? This part over here, right? Okay, let me just complete the flow. From the wait state, right? If you again want to bring the thread to the running state, right? It does not like it just comes from here to here. No, it has to go here first. Okay, it has to go here first. And then from here, right, it can move to here. Okay. How does that movement happens and all? I'm coming to that part now. Okay. But let me just complete the last part. And once you are done with the running part, the last state was dead. Right? Now, first of all, let me tell you about that sleep part, right? My thread was running, my main thread was running, and I said thread.sleep. So I purposefully made my thread go into that state, in this state. And it went there and went to sleep, right, for 5 seconds. Now, how it will return back to the running state? See, there is a concept called of a thread scheduler. Okay, thread scheduler. Thread scheduler, right? Now, right, try to understand, right? You are running a JVM application, right? It's an application. And this application is running on an OS, right? A Windows OS, right? In my case, I told you when you buy a machine, you buy with a specific processor, right? So what happens is, it is the OS which creates threads and processes, right? Okay, try to understand, right? It is the OS, right? Underlying OS which has that process, and out of those process, it has given one process for JVM to run, right? This is the JVM running that process, right? Let's say P1 process was given to JVM, and JVM will be now using that process to run your program, whichever program you're running through Java, right? Now this is process, and this would be using that thread T1, right? Thread T1, right? Now, what happens is, what really happens is, uh, this scheduler, right? Scheduler is a concept, right? Is a concept which helps you in switching from one thread to another. Okay, switch from one thread to another, right? Because what happens is, see, again, just try to understand, right? I'm telling you again, right, that it is not like that you create hundreds of threads and you think, okay, my hundreds of applications are running, right? Whereas your processor are only 8 processors, right? Ideally, it should only run 8 process in the end, right? Nothing more than that. But how are you able to run all of the combined 100 or 200 applications? Definitely there would be a load on the application, and you will see that that the performance is not very good. But it is they still run, right? Why? It is possible because of the scheduler, right? What it does is, it very smartly, right, gives the terms to every thread to run. Okay, and it switches from one thread to another, right? I mean, very seamlessly, right? So you do not get a feel of a hang, right? What you do is, it just switches from one thread to another, and it feels like, and it does it so rapidly and so fast that you do not get the feel that, okay, these are not running parallelly. Rather, they are going sequentially, but it is being controlled through the scheduler. Maybe it is during round robin or star topology, or maybe something else, right? I don't know. It is dependent on the thread scheduler, right? So what I'm trying to say is, even at the OS level, the thread scheduler is used, right, to provide the application a chance to run. Similarly, when JVM start running things, right, JVM also maintains a thread scheduler for its own application, right? And whatever threads you are generating inside your JVM, right, like how we're doing it, right, those are managed through this thread scheduler. Okay, now what happens is, let's say right, uh, let's say you have, let's say the capability of the JVM is restricted to run only 5 threads, or let's say 2 threads, just for example, right? Let's say two threads, right? And you started running the third thread and the fourth thread, right? Now JVM knows about it, right? JVM will say, okay, I know that I am capable of running 2 threads parallelly, purely parallelly, but you wanted to run 5 threads, right? And get a feeling of it, like things are running parallelly, but that is not possible. So what I should do is, I should use the thread scheduler, right, and do that context switching from one thread to another, right, and provide you your desired output, right? So that is the job of this thread scheduler, right, where that it manages all your threads and gives every thread a chance to run. Okay, now the second part. So I hope this is clear, right? The second part is, as a programmer or as a developer, right, I may have a need that I do not want my thread to run anymore, but I do not want it to complete also, right? What I want is, I want that thread to wait for a certain event to happen. Let's say I am working on a on an application which will fetch the stock prices, okay, from the market, the stock market, right? Let's say I have an application, and it will read, there is a stock market, right? Stock market, and the data needs to be received from here, right? And the call needs to be fired. It will take some processing, and it will be fired back, right? And based on the data which I receive, right, I need to take some action. Okay, but this process over here may take some time, let's say 1 minute or 2 minutes, right? Whatever that time is, right? Now what will happen is, once I started this process, right, it will fire the request, and what I will do is, I will say, okay, I know that it will take some time for this to return. Let me ask my thread to wait or get into a block state. Okay, and it will only get unblocked once I receive the response. And until I don't receive a response, maybe there is something else which my application want to do. Let me give the chance to that thread to run. Okay, so as a developer, I will create an application like this, where if my thread is waiting for something, I will ask him to wait, right? And then thread scheduler will know about it, it will manage it, and it will give the other thread a chance to run, right? So what happens is, ideally from the new state, right, you directly go into the running state. Once your t dot start runs, right, you go into this state itself. But once you reach to this state, right, there may be a case that you want to sleep for 5 seconds. Maybe you want to block, right? Maybe you want to wait for some time, right? For a certain event to happen. So what you will do is you will make your thread go from this state to this state. Okay. And once that purpose is solved, right, you will try, you want that thread to be back so that you can continue operation. So in that case, what will happen is it will not directly come from here to here. No. Now that will go into a state called runnable, right? And once the thread moves to that state of runnable, right, it comes into the notice of thread scheduler. Thread scheduler keeps tracking this runnable state, right? And it sees, okay, what all threads are in the runnable state. It means that they needs to be executed, right? And whenever it will get a slot for the thread to run, it will pick that thread and move it into the running state. Okay, so that is how the whole process of threading works, right? And once you are done with the run method, it goes to the get state, right? So I hope the thread scheduler concept is clear, right? And why these states exist, it should be also clear. Now, right? So we covered about what is threading, right? How to create a thread, right? What is the life cycle of a thread, right? Now, coming on to our part, right? The automation part. Why do we need to know about ThreadLocal, right? And ThreadLocalMap. Let's come to that part now, right? Okay. Let's say I want to create, see in my parallel execution, if I talk about, right, parallel execution, right? Let's say if people are aware about TestNG, right, they would be knowing that, let's say you have a single class, okay, you have a single class, right, and you create a WebDriver instance, right, WebDriver WD, right? Just say you said null here, right? You said null here, okay, you said null here, or however you're managing it, right? I don't care. Whatever you're doing is, let's say it is there, right? Or let's remove it. Let's put it here. Let me think what I should tell you. Okay, try to understand that this is a test case. Okay, this is a single test case, and there is another test case which I have, right? So this is for test case 1, this is for test case 2, and both the test case are like isolated test cases, right? So this is like end-to-end test case here, right? It will log in, it will open the browser, it will do everything and then log out. Similarly here, right, it will do the same step. It will log in, it will do all the steps and then log out, right? And all that, right? Now try to understand if these are like isolated test cases, right, and they are independent of anything else, right? And ideally this is how your test cases should be. They should be isolated, right? Because if you want to run a specific test case, you can just pick it up and run it. There should not be any dependency on other test cases, right? Ideally, that is the ideal approach. But again, I do understand in the real world things can be a bit more complex. But leave it, right? But what I'm saying is, let's say you have these two test cases and these needs to be run parallelly. When you say parallelly, what does it mean? It means that you need to create the instance of the Chrome driver twice, right? You need to do something like this: web driver T1, new Chrome driver, right? And similarly, WebDriver D2 goes to new Chrome driver. What this will do? It will create two different instances, right, of D1 and of the Chrome driver, right? D1 and D2. And when you do this, what happens? A new browser opens up, right? So a new browser will open up here, and new browser will open up here. This is how it works, right? A new browser will be this one, and this browser will be this one, right? And now if you want to do something on this browser, you have to use D1, right? D1.get, D1.find element and all that, right? You will do all this here. And similarly for this to work, you will do D2.get and D2.find element, right? You will have to do all of this, right? Now, if you have to do all of this, right? First of all, you need different threads, right? Because these two needs to run parallelly, right? These two needs to run parallelly. So these two needs to run at the same time, right? So how will you run it? How do you achieve this? This is achieved using TestNG, right? TestNG has that inherent concept of threading. It's very simple. We just have to apply it, and you do not have to do any of the threading concept which you have learned till now. Nothing of that, right? You have to design it accordingly in the test.xml file. It will, let's say I want to have two threads, right? I will provide the thread count as 2. What that test.ng will do is it will create two threads. It will assign T1 thread to this test case and T2 thread to this test case. Okay, and they will run. So T1, you can understand that this piece of thing is happening inside T1, and this piece of thing is happening inside T2. Okay, this is what we need. Okay, now if you see this, right, the most challenging part over here is that you need to create a new session every time. Okay, every time, right? Imagine you have hundreds of different test cases or thousands of different test cases, right? Think about it, like how, and for every thread, right, you need to have a mapping. Okay, for this thread, this driver needs to be consumed. Okay, for this thread, this driver needs to be consumed. For the thread 3, a new driver needs to be consumed, right? And try to understand, right, this is executing, right? Let's say every test case takes 10 minutes to execute, right? So during those 10 minutes, right, let's say you have 5 threads. So during this duration of 10 minutes, you are running T1, T2, T3, T4, T5 threads, right? Okay, and now for all these 5 threads, right, there are tons of codes of line which needs to be executed, right? The state of every object needs to be, I mean, has to be there, right? It has to be maintained for the thread only. It should not be that the work done by thread 1 starts impacting the work of thread 2, right? We don't want that, right? How can we solve that problem, right? The problem of maintaining the variables, right, specific to a particular thread, right? We have to use the concept of thread local. Okay, I will refine my statement. Let me write it down first, right? See, we need to know about thread local, right? Thread local. Let me just show you first of all the definition, the official definition of thread local, right? I think there it is very smartly mentioned, right? I'm not able to come up with the right words. Let me just write it here. What is thread local? Thread local in Java. Let's read this definition only. Okay, right. Now this is the part, right? Okay, let's stop responding. I don't want to see it. It says thread local is a special class in Java that helps achieve thread safety by providing per thread context, right, and maintaining them separately for each thread. So the main word is per thread context, right? What does it mean? In other words, thread local allows you to define variables that are accessible solely by the thread that created them. Okay, if if T1 thread has created a variable, right, a variable D, right, let's say web driver WD, right, it created that, right? So thread 2 will never be able to access that variable. Okay, similarly this thread will not be able to access the variables created by the other threads. Okay, but if you want to have that safety, right, that whatever this thread 1 created, right, should be only with this thread. Similarly, if what thread 2 created, it should be only with thread 2, right? What you have to do is we have to use this concept of thread local, right? Now what we have to ideally manage, see, once we design the framework, right, then it will become more clear like what is the real use case of it. But as of now, right, let me tell you, the only use case over here is that we need to manage our web driver sessions. Okay, that is the biggest part, that is the biggest problem we face when it comes to manage the parallel execution, right? If we manage that part, right, everything else, right, which we have, right, whether the POM classes, whether the utilities and all, right, that all can be managed as per our design, whatever we have designed. But web driver session, right, managing a web driver session is something a tedious part, right, which we cannot manage without the help of thread local. And if there are similar concepts to that where we want things to be very specific for that thread, then we have to use thread local only. Now let me just detail out what is this thing, right? What happens is, for let's say you have three threads, right? Let's say threads, right? You have main thread, you have main thread, you have T1 thread, and you have T2 thread, right? For every thread by default, every thread maintains a map. Okay, every thread maintains a map, and the name of that map is thread local map. Thread local map. And what does a map have, right? We have discussed that a map has only two things. What is that? A key and a value. A key and a value, right? So this thread will have its own map, this thread will have its own map, right? Thread local map, as the name says, thread local map of this thread, right? Now what kind of items I should keep here, right? And who should be able to add this? First of all, you cannot access this map as is, right? You cannot. It is something internally managed by the threads. So don't think of accessing this thread like this map, like how we usually access the other maps, right? Which we created. So you cannot access this map, first of all. Second of all, then how should I be able to add the value and read the value from it? Okay, for that you have to use this thread local. Okay, using this thread local class, you can add a entry in this map. Okay, using this thread local, you can add a entry in this map, right? Right, and this thread local, right, is very specific to a specific thread. If main thread invokes this thread local, right, it means that main is trying to add an item to its own local map, right? If T1 starts to invoke this thread local, right, it means that T1 wants to add an entry to its thing here, right? Like this only, right? So what I'm saying is, for every thread you have a thread local map which maintains these threads which are specific to that thread only, right? But how do you add an entry or access an entry or remove that entry? By using the thread local class. Okay, let me show you a demonstration. I think that will be making things more clear. I hope this is clear, right? We understood like how threads are created and all, right? This is one part. Now let us go to our actual use case, which is web driver management, right? So what I'll do is, let me create a class. Let me create a class of saying driver manager. Okay, let's say I want to create a, see what I want to, let's say my use case is I have three test cases, or I have I have three test cases. Okay, I have three test cases, and for every test case I want to generate a new web driver session. Okay, and every thread, whichever thread generates whatever session, right, it should stick to that session only. It's not that T1 generated a session called WebDriver 1 and I started with it, but it moved to WebDriver 2 to run the session, right? It should not be that one. A thread should stick to its own session, right? On WebDriver session. That is the whole need, right? Let me just say again what I'm saying, if it makes sense. See, what I'm saying is, I have three test cases. Okay, I have three test cases, and what I want to do is I want to run in three different threads, right? T1, this is T1 thread, this is T2 thread, this is T3 thread, right? And what I want is that T1, when these are three test cases, I want to run in parallel. So it means that I need to run three browsers parallelly, right? So T1 thread, how do you open a browser? You create a session, right? You create a WebDriver session. So let's say it created a session called WD1, right? And this created a WebDriver session, WebDriver 2, 3, and it opened the browser, right? Like this. And let's say every test case takes 5 or 7 minutes to get executed. But what I need to make sure is that this T1, right, should continue its work only on WD1, right? It should not be the case that during its execution it switches the context and move to this WebDriver, right? It should not do that. Similarly, this T2 should not go to WD1, right? So it should be an isolated thing, right? Only for that thread. That is what we desire, right? This is what we desire, that this is how it should be, right? So it's like that these WebDriver sessions are local to this thread. These are not exposed to some other threads, right? If we are able to achieve this, only in that case we will be able to purely run the parallel execution, else not. Okay, let's implement this. I have created a class called driver manager, right? What I will do is, how do you implement that logic, right, of thread local? You will have to create thread local like this, right? Let me go to this class first. If you go to this class, it has a syntax like this, right? It accepts a generic input called t. Okay, t. We'll discuss about it, right? So let me just say it here. Let me leave it as is, and let me give it a name. Thread local. Let's say WD. Okay, for because I'm creating this thread local for what? For web driver sessions, right? Okay, let it be. And since thread local is a class, I have to do news.thread local only, right? So I did this. I need to do this also, right? Now you can see it is complaining what I have not provided. Okay, fine. Let's leave it as of now. Let's go down and see what does it have. Okay, we have not provided the input, right? That's why it is complaining. Okay, let me say, okay, let me remove it. Okay, let me remove it. It's a generic part. Can we remove it? I think I can remove it. There is no trouble around it. Okay, I'm coming to that part. Why I will remove it? If you do this WD, right? You're not seeing anything, right? You can see you're not seeing anything here. Okay, fine, right? We observed this part, right? But if you would go to thread local, right, I think you can see there are a lot of methods here. So why I'm not able to access any of those methods? You can see there's a get method, right? It's a public method, so it should be accessible, but I'm not able to do it. There is a public method, more public methods set, right? And you can see it is accepting a input of t type. What was the t? It was something which was provided in the class signature, right? Okay. Now try to understand, right? I wanted to have in that map, in that thread local map, I wanted to have an entry in that map, right? Of what type of web driver session, right? I wanted to manage that as an entry in that map, right? And how can I make an entry? I can only make an entry through this thread local class, right? So over here, right, I will have to tell this thread local like what kind of entry I have to make in that map of the thread which will be executing this code. Okay, if I do this, let me import. I do not have Java Selenium here. Let me add Selenium. It's a Java thing. Okay, just a second. Selenium Maven dependency, right? Let's get this. 4.21 May 16th. Okay. Let me copy this and there is a dependency here, right? Let's add here. Right. So let's save this and let's reload our Maven. And we should be able to see Selenium in a while. Okay, we now have Selenium. Fine. Let's call this. Let's close this. Let's go to driver Maven update. I think it has worked, right? Let me just say yes. By that sync thing, right? It did the Maven update, right? Okay. Now thread local this, right? Now if I do go and do WD, right? Oh, why it is not giving me these methods? Just a second. Because okay, just a second. This is a variable creation, right? I can do it outside the method, but for writing a logic, it has to be inside a method, right? Let me write a method first. Public void public void. Let's say let me give it a name as init. Okay, init. Initialize means init, right? Okay, I'll do this, and in this case, what I'll do is I will use WD dot set. Okay. Okay, let me just remove this again. Let's see, can we still access or not? If I do this part and I do this, can we access it? Yes, I can access it, but you can see the written type of this, right? It is object, because if you have not specified it takes it as object. Okay. And again, as per the rule of generics, right? Right, for this part, right, if you specify this, if you specify object, or if you ignore it, you can stuff anything inside this, but we want to restrict. So what we need to do is we need to manage WebDriver session. Okay, WebDriver. So wd dot, let us here set, you can see right now it shows you WebDriver. So if you do a set here, right, like this, it requires, you can see it requires what, let me just do it again. It requires what? It requires a variable of what type? WebDriver type, right? Do I have a variable here of WebDriver type? No, I don't have it. I will provide it. So how should I provide it? If I create WebDriver wd equals to new Chrome driver, right? If I do this, what I can do is import the class, and I can let me say wd1, right? Wd is already there, so let wd1, and I can provide it here, right, like this. It has taken the input. Now what has really happened here? What has really happened here, right? Okay, so this method, right, this thread local, right, if a thread wants to make an entry into its own map, right, it needs to have the access to this thread local variable, and we want this to be, I mean, as quick as that thread can get, right, and easily accessible. So the most easiest part to make anything accessible from anywhere is what? Make that variable or method as static, so that you do not have to create the instance of that class. So let me mark it as public static. Now, if I want the access of this wd thread local, right, from somewhere else like this, what I need to do is I will come here. What was the name of my class? Driver manager. Driver manager dot, right. I can access wd, right, but I don't want to access wd. Rather, I want to get the access to this. Okay, this has to be private. I don't want to put it public. Sorry, this has to be private. This has to be public. Okay, now, right. So I want to generate this. So let me just write this thing right over here instead of this. Okay, if I do this, now try to I'll show you, right, what is happening here. So so this is to set the value, right? I'm setting the value. So this is just setting the value. There are two other methods, right, which I have to do. One is I have created an entry in the map. The entry is there. Now I want to use that entry, right? So there is a get method for it. So I will use public. Now if you use the get method, okay, let me just write it get method first. Public void get. Okay, now if I have to provide the logic, what I will do is I want to get this variable from this, right? So I will say wd dot set. Okay, wd, sorry, not set, get. Wd dot get. Okay, you can see it is not accepting any input. Get method is not accepting any input. It is just saying get there, right? If I use it, right, and I want to return this, right, to someone, so I will say return. Now if I am doing this, it is complaining. Why? Because I am using void. That variable was holding what? This variable was holding what? A session of WebDriver, right? I mean, an instance of WebDriver. So what I should write it here? WebDriver. Okay, so this is done. Now let's say I was able to set the value. Let me name it as set only. Set, right? Set and get, right? I was able to set the value. I was able to get the value. If I want to remove that entry from that map, I can say public void remove. Let's say, right? Let me just use the same words so that you do not have to learn something new. Wd dot remove, right? So this will do that. Now what is happening here, right? Let me complete the logic first, right? So this is what I did. If we understand here, right? Okay, let me remove the second thread from here. We will just work with one thread, one main thread and one thread one, right? Let me close everything else. Why is this complaining? My thread one exists here, right? Just a second. It has a problem because I did not do what. P2 not a problem. Let's remove this. P1. Did I remove something from here? This is because of this is complaining, right? Thread one. Thread. My thread one, right? Okay. Now here, right? What I'll do is driver manager dot. Okay. One more thing I have to do is I have to make them as static. Public, private, public, static, public, static. So that I don't have to create the instance of the class, right? That is the only purpose of marking them as static, right? So these are done. Now let's go here. And what I will do is my thread one and all that, right? So here, right? My thread. If I see, try to understand which line, which thread is running this line. Main thread, right? So main thread will run all the line, right? This line will be run by main, this line will be run by main, and this line will also be run by main. So if this main thread is running this set method, right? What will happen because of this? If you go into the set method, what is happening there? It is creating a new entry into the thread local map of that main thread. And what is the entry about? The entry is about a web driver which you want to add. And what is the value of it? The value of this is this session. So let me go back now. Here. Now understand this. Currently, my main thread is running. And this main thread has a thread local map within it, which it maintains, and currently it is blank. It is blank, right? Right. So this would be the key, and this would be the value. And this thread local map, right, cannot be accessed by anyone. It can only be accessed through thread local class, right? So thread local class is like the only entry. I mean, the way to reach to this thread local map, right? If you want to make a new entry in this local map, right, which is for this particular thread, you have to do through this. And if you want to make an entry to this, how can you use it? You will have to use the set method which this provides, which we did. So what we did was we did something like this, right? First of all, we said, okay, we wanted to store a web driver kind of a variable, right? So it will create like this web driver, or let's say WD here, right? WD. What name did we provide? WD here, right? New thread local. Okay, this is what we did, right? So it made an entry here, right? It will made an entry here. When you will say WD dot set, let me not use WD. Let me say thread local. Okay, I think, or okay, let's say WD only. WD, right? So WD, and if I just set here, right? It needs an input of what type? It needs an input of Chrome driver type, right? So whenever you do this, right? New Chrome driver, right? You have to understand that this object, right, would be created on the heap, right? And the address location of that, right? Or however it is, it can be accessed, right? This will have that value, right? So what will happen is this new Chrome driver, right? If it has opened up this browser here, right? The session ID, let's say session ID, right? Let's call it a session ID. This browser will have a session ID. Let's say that session ID is maintained here, right? Okay, but what is happening here is it is all happening with the context of this main thread, right? So for a main thread in its local thread local map, which was empty till now, you have made a new entry. Okay, and this session, right, only this thread knows about. Now when you will start a new thread T2, right, when you start this thread, its map would be empty. It does not have an entry. If you want to assign a new session to this thread, right, what will happen is you will have to run wd set again. Okay, that method again. It will do what? It will again create a new session, but this time, right? See, the code is same, right? This code is same. There is you. It's not like you will write this code multiple times. No, you've written a class, and there you have mentioned the set method, the get method, and the remove method, right? The set method, the get method, and the remove method. You've written that, right? But these will run only in the context of the thread which is running it. So when main thread ran the set method, right, it will do everything which can happen inside its own thread local map, right? When T2 thread started running using this code, right, it will do everything based on this thread local map. Okay, so using a same line of code, right, all the threads, right, can have their own WebDriver sessions, right? And this is the responsibility of ThreadLocal and ThreadLocalMap internally to manage it. Okay, let me just come to this part, right? So WD. So here also, right, our entry of WD will be made, and whenever you will call a set method here, right? Let's say you will call here with Firefox. Okay, so what will happen is the session ID for that session for that Firefox will be maintained here. Now let me show you all this, right, by running the code. And this is the last part for today, right? And this is the end of threading. There is nothing more required on threading, right? And it will get more clear when we discuss about it in the automation frameworks, right? But I still wanted to give you that thing, right? Because this is the most crucial part when it comes to designing the parallel execution. Okay, right? So let's go here, right? We have already designed this, right? You can see this is only this is one class, right? And it has all these three methods: set, get, and remove. And thread local is only one, right? What I'm going to do is over here, right? Let me just change this thing a better, right? What I will do is I will say user to provide me a browser name. Okay, like this. And here I will say if browser name equals, no case, Chrome, right? Then do this. Okay. Then do this. Else if browser name is Firefox, it's Firefox, then do what? Do this wd.set new Firefox, right? And if there is nothing of this sort, then do what? wd.set new Edge driver. Okay, we're okay with this part. Now what will happen is, based on the browser name I will provide, it will create a session of that browser and assign to that particular thread. Now let's go one by one now, right? Let me just remove this line, open this driver manager on the right hand side. Okay, open the right split, and let me close all this. Okay, now here, now see this, right? This is the main thread running, and thread for this main, the thread local map is empty right now. I have to create a new entry inside the thread local map, right? So what I'll do is I will say okay, create an instance of my Chrome browser. Now what will happen is, once this method gets called, it will receive here, right? And it will read this line and it will do this wd.set. Now what will happen is, in the thread local map of this main thread, an entry would be created, right? The key would be what? WebDriver wd, right? Wd over there, right? And what would be the value? The value would be the session ID of this session, right? Let's say, right? Now this is done. Okay, this is done. Okay, and now let's say I want to get the access to that session. Okay, so what I'll do is I will do something like this. I will say I will create a local WebDriver here. WebDriver, let's say main driver here, right? Main driver. And Okay, let me import the class. And what I will do is I will say driver manager dot get. Okay, what this get method will do is it will go inside that thread local map, right? And it will see what is the instance, what is the value for this driver manager. And what was this driver manager? You can see what is this doing is it is fetching me the instance of the web driver. So it will get the session ID and it will assign to this driver here, right? So what I'll do here is now I will say main driver dot get and provide me the URL here, right? Let's say https podtest.in. Okay, I'll do this now. Okay, see, as of now it seems very simple, right? You will think, okay, Akhil, you are doing in sequential way, so it's setted. So until now we have only one session only, right? So why there is a need to do all of this extra work? I'm coming to that point, right? See here. So here everything is happening in the main thread only right now, right? Now what will happen is main thread. Now the next thread is getting created, right? But still main is the one which is running, right? This new thread will only start where? At this line, right? At T1 not start, which is here. Now when this thread will start, right? I want to have a I want to start a new thread. I want to start a new driver, right? A new driver where I will open some other website. Okay, so let me do this. So I will go to the run method of this class, which is thread my thread one, right? This one, and over here I will create a new section for it for this thread, right? But I do not want to. I want to make sure that it should not start using the session which was meant for main. I don't want to use it, right? I want to create a session specifically for this thread, and I will do it using this thread local. What I will do here is I will say driver manager dot set. Now what it will do is, you know which thread is running right now? The T1 thread, right? That T1 thread is running now, right? Not the main thread. All this line of code is getting executed by T1 thread. So the thread local map of this thread is empty. It is blank, right? I want to make an entry in that map. So what I'll do is I will go to driver manager dot set and I will now provide Firefox. Okay, Firefox. I did this. Okay, so the entry is made. What I will also do is I will retrieve it back. I could have been smart. And I could have written WebDriver here itself, right? And I could have made a written statement like this, return WD like this, right? It would have made my work easier, but let it be, no worries. I do not have to do that get thing again, but let it be. What I'll do is I'll create a WebDriver session, a WebDriver variable here, WebDriver. Let's say T1 driver here, right? And import the class. What I will do is driver manager dot get. Okay, now try to understand. I have two threads, main and T1, and both have a thread local map, right? A map, right? And now both have an entry of this driver manager, right? Right, I mean in that driver manager, right? This thread local web driver, right? They have an entry for that. And what is happening is, for the main, the entry is about the Chrome session, and for T1 the entry is about what? Firefox session, right? And these are only available to these two threads specifically, right? T1 does not have access to this session. Main thread does not have an access to this, right? Okay, fine. Now I got this, right? What I'll do is I will say T1 driver. Okay, and what I'll do is I will say T1 driver dot get, and this time I will use what? I will say, let's say HTTPS. Let me use a demo website. Okay, let's just use this, and here I'll provide this value. Okay, now so I have opened this up, right? I'm doing this part now. Okay, what I will do now, let's say it started the thread, right? The thread is executing, right? And now I have two sections opened up, right? Here, right? I want to do what? I want to continue my work on this driver, right, of the main. So I will do what? I will say WebDriver dot navigate, and I will open this https youtube.com/podcast, my YouTube channel. Okay. Okay. Why it is complaining? Oh, a new URL, right? It accepts new URL, I believe. Okay, sorry. Yes, so let me import this thing. Why it is complaining? Navigate method accepts what? Navigate to. Sorry, my bad. My bad. Navigate to, and I can just provide the URL, right? HTTPS uh, youtube.com/podcast. Okay, so let's observe like what is happening, right? You will see there is no mix and match. Okay, it is no mix and match, and they will run sequentially, right? I mean the way it should work. So main thread will stick to its session of Chrome, and T1 will stick to its session of Firefox, right? They will not do that mix and match kind of an operation. Let's run this and see what happens here. And you can see I am able to generate both the sessions using the same code, right? This is a big win. Okay, people don't understand what is the purpose of this thread local and how it really works. To understand thread local, we have to know that every thread has a local thread map. Okay, and the way you can make an entry to it is through this thread local only, right? Till now, as of now, that map only has one entry, which is for that WebDriver part. I will again make an entry to it of something else. We'll talk about it. Okay, just after running this, I will show you that part, and we are done for the day. Okay, uh let's run it. Let's see two browsers getting started, one on the Chrome and second on that, and you can see two threads will be running, right? See, so this Chrome has started. It was so quick, it went to this. Okay, where is the Firefox? Okay, see, it has not complete, right? It is still running. See, Firefox has opened up now. Where is the Firefox? Here, right? It has opened up now, right? See, scheduler is the part which is doing that thing, right? All these things. But try to understand Firefox, right? On the Firefox, this is the session. This is the thing which it has to run, right? Is it launching synchronous way? No. See, again, you have to understand this is if I would create multiple threads here, right? Okay, let me do one thing. Let me create multiple threads. Then I think it would be much more clear, right? To see this. It is not synchronous. It is, you have to understand that thread scheduler is something which is doing all these operations, right? So it is up to the thread scheduler when it will decide to run that thread, which we are creating as an extra thread. Okay, it is not on us. It is the responsibility of thread scheduler to decide. You have said that start the thread, but you have only given the instruction. You are letting thread scheduler know that you need to run this. Okay, that is the kind of information you're passing. It is up to the thread scheduler when it decides to run it. You do not have any control on that. If it decides to run it in the end, it will run it in the end based on what kind of information it had, right? So let me close this again, and I will do one more thing. I think let me over here, right? Let me put a thread.sleep. Okay, let me put a thread.sleep of let's say 10 seconds. Okay, I can do a milliseconds, right? Okay, 10 seconds. Let's see what will happen in this case. Add exception, no. Surround with tie catch block. Ideally, if we have a thread.sleep, it should wait here for 10 seconds and do nothing, right? After opening this, it should not do anything. But which thread is going to sleep? Main thread, right? But the point is the main thread is sleeping, right? If it is sleeping here only, right? It has not even reached here. So let me put this thread.sleep here. Not here, maybe here, right? When I'm starting this thread after this. Okay, let's see what will happen now. The main thread will go to sleep, right? And only then this should run. Okay, let's run this. Let's see this. And I will do one more thread. Okay, let me run this first. Ah, so it opened the Chrome browser. It will go to my. Okay, it is not going. See, the Firefox browser opened up, right? Why it is not going to my default website? Okay, but you can see this time, right? Both are happening parallelly. Okay, let me close this. But I just wanted to understand why I did not use my first website. HTTPS, right? HTTPS. It has to be HTTPS. Uh, WinDriver.cat, right? So so it opened the Chrome browser and it went to podtest.in. It went to that site, and in the meanwhile, the Firefox browser should open up. Right? You can see Firefox opened up and it has not navigated to the pod test yet. It went to the pod test after 10 seconds were over. Okay, just a second. Sorry again. My knees. Okay. What I was saying is, you can see, right? What happened was the browser, Chrome browser, opened up first, right? And then the second thread started, right? In the first instance, I mean, the website was reached, and then the second thread started, right? And it is running on the Firefox only, right? And then it went to the thread again, right? This thread one again after it waited 10 seconds, and it ran the second step, right? But the point here is that both the threads, right? See, I have not used testng here, right? First of all, try to understand. I have not used testng here. I am using the basic concept of Java, right, to create different threads and achieve parallel execution, right? And you can and the same thing, right? Internally, testng would be doing it inside this, right, to achieve all of this. Okay, but how it is managing all this, right, or creating the sessions, that's a different thing. But managing the WebDriver sessions is a different concept, which you will have to also take care of when you use testng. And how do you use it? You use it using ThreadLocal, right? Like how we are doing it. Okay, let me just show you the last part. If I now create a new thread using this class itself, right? Thread2. The thread2, right? I will create a new thread, thread2 here. Okay, thread2. Let me create this class, thread2. Here, right? Thread2 here, right? Oh, sorry, thread1 is this class, right? And here I will provide thread2 here. Okay, and I will do what? I will do the same stuff. Okay. Okay, and here, right? I will also do one more thing. This is my thread. I will create a my own constructor here, right? I will change something here. I will say public my thread. I'm trying to enhance the power of the thread. I will take an input from this. String browser name, public browser name, browser name. This, why is this complaining? Public string. This dot browser name equals to browser name. Okay, so I will be receiving it, and whatever browser name I receive, right, I will set it here. Instead of hard coding, I will set the value here, right? I will do this, right? Whatever it will do that, right? Now, and let me also take the URL also. I think it would be better. Let me take the URL also. Public string URL. Okay, URL here. String URL, and I will do what? I will say this dot URL equals to URL, right? And I will provide this URL here. Okay. Now I will go back. Okay, let me do one more thing. I will also like to print here like the kind of browser and this URL information I have. So I will print here s out, and I will print thread.local name get name, right? Okay, get name. Uh, browser is browser is browser is what? Browser name. Okay, this is the browser name. This dot browser name. Sorry, the browser name, and I will print the same information for the URL also. URL is this. See, by doing all this, I'm just trying to show you the power of threading, right? That's it. URL, and we are good with this. We are okay with this. Now get back to this, right? Now this time, right, when I have to do it, I will here itself tell what kind of things I need. I need to run on Chrome, and I want to open which browser. I want to open, let's say, this browser, right? Let me not this browser, the other browser, which is this. Okay. So let me close this. Let me close this, and I need to use this one for this thread. Okay, for this thread, and for the other thread, let's say I will open on the Firefox. Okay, and on the Firefox also, let's say, okay, I will not use this one. Let me use https google.com. Okay, now you can see what all I'm doing, right? I've started the thread. I'm doing all this t2.start. Okay, I'm doing all this. Okay, let me do one more thing. Sorry, just one more second. Let me use this only, right? And what I will do is t2.start, t2 this, all this. This is it is opening up the URL, and let me do one more thing. I will say t1 whatever the t1 driver is, t1 dot get find element, right? Find element by dot xpath, and here I will fill the value as input at the rate name equals to email, right? That's it. And I will say dot send keys. I will say Akhil here. Okay. So okay, I am sending Akhil here, right? And in the other, okay, this is what I will do. Okay, let me get this value also from the user only. So Akhil will fill here. Uh, just one last second, right? Sorry guys. string test data. Okay, and let me say public string test data. Test data, right? And I will say this dot test data equals to test data, right? And I will come down and I will say this dot test data. And from the first thread, I will pass what? I will pass Akhil. And in the second case, I will pass Jan. Okay. So it can be further bifurcated, right? You will see most of the difference when you run it in the full-fledged way, right? All the test cases. Then it will make more sense. Since I do not have the code ready for showing you all of that, let me just run it and show it to you, right? Now this time 3 threads will run. Okay, 3 threads will run, right? But again, it is up to the thread scheduler how it maintains it and runs them, right? But let's see what it will do. But try to understand each thread has its own copy of the web driver, right, which it will consume and retain. No other thread will be able to access that session. Okay, so let's run this. So there would be 2 Chrome browsers and I think 1 Firefox. So main thread and T1 thread will run on Chrome and T2 will run on Firefox. Okay, let's start this. So Chrome browser opened up. So this is the main thread which is running, right? You can see it opened pod test. It has opened a new Chrome browser, right? You can see. So this is T1 thread running, I believe. It has filled a Achille, right? T2 thread has not started. It has started now, right? And it will run this. Okay. And but the main point is that you are not mixing up the work, right? They are isolated getting worked, right? They're only working on their particular sessions. It is not possible to achieve this without using ThreadLocal. Okay, it is not possible, right? You can see after 10 seconds it moved to this thread, main thread, and loaded that pod test URL. Okay, right? One last thing which I wanted to show, one last thing, really last thing, is this part. This is driver manager, right, which I did. Let me say I want to store something else. Let me create a car. Okay, let me create a car variable. Let me create a car. Okay, let me create a car. Let me create a car, and here I will say public string name. Okay, and I will use the help of this and generate some getters and setters for it. Getters and setters, yes, and yes, do it. So it generated this getters and setters for me, which is fine. What I'll do is I have created this thread local, right? Using this what driver manager, right? Let me create a car manager also. Car manager, okay. And here let me copy the code of this. Now you can see I am trying to make a second entry in that map. The first entry in that map was about WebDriver. The second entry in that map for those threads would be what? About car object. There was no need to show you this, but I'm just trying to make sure that you understand what is the purpose of thread local. Okay, thread local helps you to make an entry to a map, right? Whatever variable you want to make an entry for, right? Earlier we made an entry for WebDriver, now we will make an entry for a car. And this will stay only for that thread, nothing else. So it was WebDriver, right? Let me say car. Okay, car. Let's say car. Okay, so this is done. It has taking browser name, right? Let me say car name. Okay, and let's just remove all this. I don't need. What I need is wd dot set, sorry, car dot set what let's say Honda. Okay, Honda car, or not Honda, sorry, I have to take it from here, right? Not from there. Okay, so this is done. Okay, Okay, why can't I take it the car? Oh, because this is, oh, sorry. I don't have to provide this. I have to say car here, right? Car. I have to provide the car object. So car, uh, car local. Let me say car local. Okay, car local. So this will be car local, car local, car local, car local, and this would be car, right? And this would be car, car here, right? Small car, and I will add this car here, right? Okay, so this is all good, right? And what I need to do is I will go inside my individual. Let's go into the main method. You can see I have made, when I did this, right, I made an entry in the map of the main method, the main thread. I have made an entry in the thread local map of the main thread for this web driver, right? Now I will be making another entry. This time I will be making an entry for car manager, right? Dot set, and I will make an entry over here, new car, and let me do one more thing, new car, right? Let me create a constructor for this, public car string name, this dot name equals to name, right? And I will go up here and need to provide the value, right? Let me provide Honda. Okay, so Honda car is specific for which thread? Main thread. Let me use this as is, and I will go here, right, inside these threads, my thread one, right, and I will make an entry here, car manager dot set, let me say, and this value I will also accept from the user. Okay, so I will say string car name and public string car name, this dot car name equals to car name. Okay, and what I need to do is I will go down and just remove this part and make it generic, this dot car name. Okay, got. And let's go back and just make the change here. This time for this, I will provide the car to be, let's say, Ferrari. Okay. And for this one, I will say, let's say, Alto. Okay. Right. Now try to understand what is happening in this case. I have created two thread local, right? And both of them has a responsibility to make an entry into the thread local map of their for the running thread, right? So if I go back here, right, on the drawing board here, right, if you would look at this, right, earlier we have now two thread locals, right? One thread local has a responsibility for managing web driver, right? This web driver which is managing the session. Another thread local, right? This is the first one, and the second one has the responsibility to manage the car, right? Whenever you will say this using this thread local, you will do a set, right? And whatever thread it is running for, right, it will go and make an entry here. So you were able to make an entry for web driver earlier, and whenever you do this car part, right, it will make and go and make an entry for this car object, and here it will be make an entry for Honda for the this part. Okay, this is doing this. When it will be thread one, right, it will be going and making an entry. This thread local for this will go and make an entry for this car, and this time it will be new car, and this will be Ferrari, right? And there would be another thread T3 which we are creating now, and for this it will be the web driver session also and the car also, right? This time it will be for Alto. So try to understand this map, right, can only be filled using thread local, if right, and one thread local will manage only one entry like this, right? It is not that you can keep on adding multiple entries using one single thread local. No, thread local needs to know what kind of entry you're making, right? So I have to create two thread locals. One thread local is about web driver, second thread local about the car, right? And if you run the set method again, right, it will rewrite the value which was already there. like how it works for the maps also, right? So it will rewrite that. Okay, so try to understand. Again, I'm revising, right? Just understand this concept. We have for every thread we have thread local map, and you can make entry to it by using thread local. Okay, and within thread local you have three methods using which you can interact with this map: set, get, remove. Set will make an entry, get will fetch that entry, remove will remove that entry. Okay, and this is what we have to use when it comes to parallel execution management in the Selenium part, and this is what we have to learn, and we have already covered this. So when we will discuss about our framework designing, right, using the parallel execution, we will be just implementing this part, right? And this is the only part which you have to which you have to be concerned about threading, only this portion. Although I told you about the other things also, right, all this which we discussed, right, but this is good for your knowledge. If you want to, I mean, if you think this is a value for us, please remember this. Otherwise, just remember the last part which I told you, right? Okay. Okay, I think we are good for today, and let's meet tomorrow. I'll update you about the tomorrow's topic, but threading is done from our side. Okay, thank you so much for joining. If you have any questions to ask, please feel free to ask. Otherwise, we can wrap it up. Okay, thank you so much for joining. Let's meet tomorrow. Bye bye. Take care.
Thank you, sir. Bye. Good night.
Thank you. Bye bye.
Thank you. Bye.
Thank you.